Hello, my dear students. So, in this chapter, we'll be discussing about the potential difference or the voltage in a dry cell or else any source of electricity. Right, now in the earlier chapters, we have discussed about the electric current and how to measure it. Now, this is another type of a measurement that we take when we are dealing with electricity. So this measurement is referred as the potential difference or the voltage. Now let's see what is this potential difference or this voltage is. Right. Now, before we are going to discuss about the potential difference, you are given with a certain figure here. If you check it very clearly, this is a figure of a small bit of a waterfall which is being created on a certain pond, right? So maybe at your home garden, right? These types of small waterfalls can be observed, right? So these things are made by specially from a water pump like this, and the water pump is going to pump out water to the top of the waterfall, and when it is being pumped to the top of the waterfall, it will have some amount of potential energy due to change in the vertical height of it, right? So you know, when change in vertical height of a certain object, an energy, a type of an energy is getting created on the object, right? This energy is referred as the potential energy. So in the same way, when you pump water to the top of these cliffs, the potential energy stored in water is somewhat higher than in the initial location when it is on the pond, right? So therefore, due to that potential energy, the water will come down as a stream towards this pond. Then once again, the water is going to pump to the cliff by using the water pump. Once again, due to high potential energy, the water will come down to the pond. So it will move as a cycle. You can observe it. So here you can observe the waterfall. Right, here you can observe the waterfall. This part where the water is going to come, right? And this is the pond. This area is the pond, and here you can observe the water, and water pump is here. So water pump is going to pump water to the cliff or to the waterfall, right? So here it's given that you may have seen ponds and waterfalls designed in modern houses which function with the help of water pump. Pond water has less potential energy. Now in this, when you take water in this pond, right, it has lower potential energy because it is at the ground level, right? So if you want to increase the potential energy of this water, you have to take it to a somewhat height. So by using the water pump, we are taking that water into a certain height to increase the potential energy, right? So here, pond water has less potential energy, but when water is pumped up to the waterfall, more potential energy is stored, right? So more potential energy is stored. So here you can observe in a certain waterfall, in this level where the pond water is going to exist, it has very less amount of potential energy. So potential energy, I'll mention it PE, right? Potential energy less. So here I'll mention as less. right? And in the waterfall, more. On the point of the waterfall, right, the potential energy is more. So here you can observe there is a difference between the potential energies between these two levels. There's a considerable difference, right? If you assume in here the potential energy is 0, then here it is about 100, right? Here it is about 100. So automatically what will happen here is water will come down the hill towards the pond because of these potential difference, right? Because of this potential difference. So in the same way, if you take a certain electric source, in order to flow electrical charges from one terminal to another, you know that if you take a certain electric cell or else a dry cell, the electrical charges is going to flow from positive terminal to negative terminal. In order to flow electrical charges in that manner, like in this figure, in that situation also, there should be a considerable change between the charges. Here, the electrical charges. So you know that there is a so you know that if you take a certain electric source, there is a positive terminal and a negative terminal, right? So if you take the two terminals, positive and negative separately, these two terminals should have a considerable change between their charges. Otherwise, the charges will not flow from one place to another. Like in this figure, right? The water in the pond is very still. It can't move. It's because that it is at the same potential level. So the potential energy whereby all water particles within the pond is equal. So therefore there is no potential difference there. Means that water which is on the pond is in still or is at rest. It's not moving. But if you take the water which is at the top of the waterfall and the water which is at the bottom of the pond, in these two areas there is a considerable change between their potential energy. So in this situation, definitely the water will flow from higher potential energy to lower potential energy. That's why in a waterfall, water is going to drop down towards the pond in this figure. So in the same way, if you take an electric source, there are two terminals in an electric source. So there should be a considerable change between the charges in these two terminals in an electric source. So this difference between the charges, electrical charges in an electric source is referred as the potential difference between the two terminals or the voltage between the two terminals. So let's move on with our next slide to observe what do you mean by this potential difference or the voltage. The process of electric circuit takes place in the same manner. Dry cell provides electric potential energy to electric chargers. So I told you that in the earlier case, when water is going to flow from one place to another, there should be a considerable change in their potential energy, right? Like in the same way, if you take an electric circuit, in an electric circuit, we can observe there is a potential difference between the charges, right? Between the electrical charges in a circuit. So the dry cell is the one which is providing this potential difference, right? So here, the process of electric circuit takes place in the same manner. Dry cell is the one which is providing electric potential energy to electric charges. At the positive terminal, the potential energy is very high. At the positive terminal, the electrical potential energy is very high. Okay, that's how the dry cells are being made up with, to have high potential energy at the positive terminal. Then at the negative terminal, we can observe very less amount of electrical potential energy. So at the positive terminal, potential energy is higher than the negative terminal, right? Than the negative terminal, we can observe high potential energy at the positive terminal. So that's why the electrical charges is going to move from positive terminal towards the negative terminal, right, my dear children? So this is the specialty in electrical circuits then. That's why the electric current is also going to flow from positive terminal to negative terminal, because at the positive terminal, potential energy is higher than the negative terminal. So in the third point, you can see the difference of electrical potential energy between the two terminals of the cell is called the voltage or the potential difference. Voltage or the potential difference means this difference between the electrical charges between the positive terminal and the negative terminal in a certain electric source, right? So this is called as the voltage or the potential difference. Electric current flows from a higher electric potential to a lower electric potential, obvious, right? It's because that always, all the time, if you take a certain thing, all of these things are going to flow from higher level to a lower level. Any kind of a thing, any kind of a material is going to flow from higher level to a lower level, right? Like in the same way, electrical charges are also going to flow from higher potential to a lower potential, means that from positive terminal to the negative terminal. So electric current flows from higher electric potential, positive terminal, to a lower electric potential, which is the negative terminal. Voltage between positive terminal and the negative terminal of electric cells and the batteries is marked on them. Usually if you take dry cells and batteries, the potential difference means the difference between charges, electrical charges at the positive end and at the negative end is being marked on the cell, right? On the surface, on the surface of the cell, it's been marked this amount of potential difference, this much amount of potential difference. So like that way, there are several kinds of cells. You could observe that there are several kinds of cells in the market. Now, in all of these cells, they have different amounts of voltages or potential differences, right? Okay, so these are the most important facts that you need to learn about potential difference. So let's see how or what are the other things contained in this potential difference thing, right? So here you are given with different types of cells. Here you can observe a button cell. This is called as the button cell, right? So this is a 9-volt cell, right? You are familiar with this and this, right? In toys, we have to use these types of somewhat larger cells. And this is called as the lead acid accumulator or the battery, car batteries. And this is just a AAA battery which we used in our remote controllers, right? The size is referred as the AAA, right? It's referred as AAA dry cells. This is the size, right? This A letters represents the size of it. In a dry cell, right? These A letters represents the size. So if there are 3 A's, triple A's, then that's a small bit of the dry cell that we used in our remote controllers, right? So there are different types of cells in here. Now, in these cells, the voltage is being marked or the potential difference is being marked. Here you can observe 12. Here V letter is given. That is to represent the voltage, right? So the voltage is 12. We'll come on to the unit that is used to measure the potential difference later, but just for now you focus on these values. Okay, so here 1.5 volts. So volts is the unit that we use to measure potential difference actually. So here V means volts, right? So we'll be coming on to the unit and we'll be discussing about the unit later with the lesson, but just for now focus on the number. So here you can observe 9. Voltage is 9 volt. And here you can observe the voltage is 3 volts, right? So you are given with an assignment. At home, you can do this assignment. What is that? Collect as many as possible electric cells and batteries which are used commonly. So these are some examples. Observe how the positive and negative terminals and the voltage values are marked on them. Then you have to observe how does the positive and the negative terminal is being differentiated, and also how does this potential difference or the voltage is being marked on them, right? And if you want, you can tabulate the values, right? So you have to do this thing at home. You can collect several cells at your home. So prepare a table then finally of the cells you collected and their voltages. So finally you have to prepare a table. So at home, my dear children, you continue with this assignment. Find out different cells. You can go visit your relatives, or else you can collect several things at your home also, right? Then collect these cells, find out their voltages and tabulate them, right? Okay, so I have also mentioned here several voltages. How does the voltage is going to, or the potential difference is going to change from cell to cell. So in different types of cells, we can observe different types of potential differences, right? So let's move on with the next slide to observe what are the other contents in our lesson. So my dear children, you have to remember to do this assignment at home, right? Find out different cells and record their voltage. Usually the voltage is printed by using capital V, like in the ammeter, right? When we are used to measure current, capital A is being mentioned, no, in an ammeter. So like that way, V is printed, V. Capital V letter is printed to show the potential difference or the voltage in a certain type of an electric cell, right? This V letter reflects the unit of it. It's the volts, the amount of volts, right? That's the unit that we use to measure the potential difference. Right, so we'll move on with our next thing. So you are given with a table here. This is related to potential difference. All the things that you need to learn about this potential difference or the voltage. So first of all, given symbol for the potential difference. Symbol. For the potential difference, we use a special type of a symbol. Right? So this symbol is V, capital V. Right? In the earlier case also, we studied that in dry cells or in several cells, the voltage is printed by using capital V thing. So that is to reflect the voltage amount of it. So we use capital V letter to represent the voltage. Right? So symbol for the potential difference is capital V. Right? Then International Standard Unit or the SI unit for potential difference. SI unit for the potential difference. Right? SI unit. SI unit for the potential difference. So International Standard Unit for the potential difference is, like in the earlier case, I told you, we measure potential difference by using volts. Right, my dear children? What's the unit? Volts. Volts. So, volts. Volts. So, the International Standard Unit or the SI unit for potential difference is volts. V-O-L-T-S. Volts. Then next one, symbol of the unit used. Symbol. Now, when you are looking about that dry cells, you can observe 12, then there is a capital V, means it is 12 volts. 12 volts. Right? So here also the symbol of the unit is capital V. Capital V. To mention the potential difference, we also use capital V, and to represent the amount of volt using the unit, in that case also we use capital V. Then the next one, equipment used to measure potential difference. Right? So the equipment that we use to measure potential difference is called the voltmeter. This is referred as the voltmeter, my dear children. Voltmeter. Right? So we use voltmeter to measure the potential difference or the voltage in a certain circuit. Right? We use voltmeter. So the equipment used to measure potential difference is called voltmeter. Voltmeter. Right? So equipment used to measure potential difference is called the voltmeter. Voltmeter. Right? Voltmeter. Then symbol of the instrument. Once again, it's capital V. Right? So which used to reflect about the voltage. So we use most often capital V. So capital V is the symbol of the instrument. So here capital V, then we have to connect it to the circuit. No, this is the way. And like in the ammeter, there are two terminals in the voltmeter, right? So usually we name these two terminals like this in the voltmeter also. So this is the symbol, right? So I'll mention the circuit symbol. This is the circuit symbol, right? Circuit symbol of the voltmeter is this. Right. So this is the circuit symbol for a voltmeter, right? So once again we'll see what are the things that we have learned about this potential difference then. So the symbol for the potential difference is capital V. International standard unit that we use to measure potential difference or the voltage is volts. Then we use capital V letter as the unit, symbol for the unit. Then the equipment used to measure the potential difference is the voltmeter. Circuit symbol or the symbol of the instrument is like this, like in the ammeter, but here we use capital V, right? So capital V, then the two terminals plus and minus, right? So these are the things that we need to learn or study about the potential difference, my dear children, right? The most important things related to the potential difference. Right then. Now let's see how to measure the potential difference or the voltage in a certain circuit or else an instrument. So this is called as the voltmeter, right? This is the voltmeter. Here you can observe a red color terminal, which is the positive terminal, and the black color terminal here, which is the negative terminal. Usually we use red color to indicate the positive terminal and black to show the negative terminal. In each of meters we can observe it, right? In an ammeter, in a milliammeter, microammeter, galvanometer, then even in voltmeters also we can observe the positive and the negative terminal by using red color and black color separately, right? So like in the ammeter, but in here capital V letter is printed on the base of the voltmeter and there is an indicator like this, right? There is an indicator like this. This is the indicator. So when you connect these two terminals to a certain electric source like this, these two terminals, when you connect it, right, this reading will move to indicate the amount of voltage in it. So here the scale is marked from volts. Scale on the voltmeter is being marked from volts, right? So here it is given, see, there are positive and negative terminals in voltmeter. Usually positive terminal is red and negative terminal is black. This is the most important one, my dear children. Connecting a voltmeter to a certain circuit. So here it is given that voltmeter is connected parallelly to the circuit to measure the potential difference between 2 points. So we have to connect it parallelly, right? Or else we have to maintain a parallel connection, right? So in the earlier chapters, we discussed about what do you mean by a parallel connection and what do you mean by a series connection. So in a parallel connection, we have to directly plug in the 2 terminals of the voltmeter towards the electric equipment or the electric source that we are going to measure the potential difference or the voltage. We have to directly plug into those 2 terminals, right? So when you are plugging in the voltmeter, be careful about the positive and the negative terminals, right? You have to fix it very correctly, right? Otherwise the reading will go on to the other side. So by that, so if you connect it like that way, we can't get a clear observation or else a clear reading. So remember to connect it in a proper manner, positive to positive, negative to negative. Okay, right? So here, remember, always we connect this voltmeter parallel to a circuit, right? So whatever the electric source, we have to connect it parallelly. So I'll show you how to connect this voltmeter in a parallel connection. Like if you want to measure, so I'm going to use a circuit symbol. So these are my dry cells. There are 2 dry cells. This is the bulb, right? So now I need to connect my voltmeter to measure the voltage of this bulb. So it's really easy to connect. You take the voltmeter and directly plug in the 2 terminals like this onto the electric source which you need to measure the potential difference. So you directly plug in the 2 terminals onto the bulb like this. So this is the parallel connection. We discussed about these things in the earlier chapters. You could remember. I have explained about the parallel connection and the series connection very well by drawing out the figures, right? So here, always remember this terminal, this one should be the positive terminal of the voltmeter, because here you can see this is the positive, the longer terminal, and the other terminal, this one should be the negative terminal of the voltmeter, this end, right? Don't interchange the 2 terminals, otherwise you will get faulty readings or your readings would not appropriate, right? So you have to connect it very carefully, positive to positive and negative to negative, like this. So this is the way of connecting a voltmeter to a circuit to measure the potential difference, right? Okay. So my dear children, now we are about to measure the potential difference or the voltage, right? So here you are given with an activity, measuring the voltages of some cells and batteries which are commonly used, right? So we are about to measure the potential difference in certain dry cells and in certain batteries that we used in our day-to-day life. So you will be needing these materials when conducting this activity, So you will be needing several dry cells and batteries. So here this battery is, or this dry cell is remote cells, right? Remote cells. Then button cells. For remote cells, we mention this one as AAA sized dry cells. AAA size. AAA size means remote cells. And the button cells we use in our washers, button cells. And most of the times we use in remote controllers as well, right? Like in AC controllers. So in these in these special kind of remote controllers also we use the button cells. But most often we use these button cells in our washers, wristwatches, right? So button cells. Then definitely you will be needing voltmeter, then connecting wires to connect the circuit, connecting wires. Then this is called as the lead acid accumulator or the battery. So I'll take it somewhat up. Lead acid accumulator. In simple, we refer this thing as car battery. Then this is the 9-volt cell, 9-volt dry cell. So you will be needing different types of dry cells and batteries, right? In each of these electric sources, we are about to measure the voltage, right? So you'll be needing these materials. If you can find out even more different types of dry cells and batteries, then that's also okay. Some rechargeable dry cells, right? Somewhat larger button cells, right? Like that way you can find out different kinds of dry cells and batteries in here. Then a voltmeter. So by using some connecting wires, connect the positive end of the voltmeter to the positive end of the electric source and negative to the negative end. Then by that way you can measure out the potential difference, right? So these are the materials need. So we'll head on to discuss about the method. So it's really simple. Connect each of these electric sources or else dry cells and batteries to the voltmeter and record your observations, right? That's it. So I'll write down the method. Connect each cell separately to the voltmeter then record the voltage reading. So it's really simple to conduct this activity. We just need to take these dry cells or these cells and we need to connect it with the voltmeter. Then after that we need to record the observations or else the readings given out by each of these instruments, right? So my dear children, this is the way of conducting the activity, right? So we'll move on with the laboratory and we'll continue the experiment over there, right? I have several types of dry cells and cells with me. So let's move on to the lab and we'll conduct the experiment and we'll see what are the readings of these instruments, right, my dear children? Now here I have several batteries and dry cells, right? So first of all, I'm going to let you know what do we mean by a battery and a simple dry cell. Now these type of instruments or these type of electrical sources are referred as batteries. These things are somewhat larger than these dry cells, right? Larger than these things. Specialty in these things is that we use a special type of an acid with some metals, right? These are also called as lead acid accumulators. Lead acid accumulators. So there are several knobs in here, right? There are several knobs in here, right? We can remove these each knobs and if you want, you can add the acid when time is going to pass by. The strength of the acid is going to reduce. In that kind of a situation, you can remove these pins by using a spanner or else a screwdriver, and you can insert the acid onto this lead acid accumulator. So these things are very heavy. For vehicles, we use these lead acid accumulators, right? And these things are called as dry cells. These are dry cells because we use dry materials or dry chemicals in making dry cells. So now we are going to observe what is the voltage value or the potential difference in each of these electrical sources. So first of all, I am going to take this lead acid accumulator. So most of the times in a lead acid accumulator or else in a battery, right, the specifications are printed in here. Specifications are printed in here. So you can observe it's saying that 12 volts. 12 volts. You can see there is 12 volts. So 12 volts means the potential difference. The potential difference or the difference between the electrical charges of the positive and negative terminal in this battery or the lead acid accumulator is about 12 volts. 12 volts, right? So it has 12 volts of a potential difference. So if you check it clearly, you can observe in the figure here. See, in this figure, you can observe there is 12 volts clearly. Okay, now I'm going to take each of these dry cells, right? First of all, I'll take this square shaped dry cell, this one. This dry cell is a 9 volt dry cell. This one. This is a 9 volt dry cell. Positive and negative terminals are printed here. So this terminal, this one is the negative one and this terminal is the positive terminal, right? This is the negative terminal, this is the positive terminal. So here you can observe the 9 volt sign can be clearly observed in here, right? The 9 volt sign can be clearly observed in here. So this is called as the 9 volt dry cell. So the potential difference or the voltage of positive and negative terminal or the difference between the electrical charges between positive and negative is equal to 9 volts. 9 volts in this one. 9 volts. The potential difference is 9 volts in this dry cell. And I have another dry cell. Most of the times we use these dry cells for our torch flashlights, right? So in here, let's see how much is the voltage in this one. So if you observe this end, see, you can observe the 1.5 volt sign. See the 1.5 volt sign in here. So you can clearly observe the 1.5 volt sign, right? In here, see, you can observe. So the potential difference between positive and negative terminal of this dry cell is equal to 1.5 volts. Normally in these torch batteries, like these things, and these batteries which we used in our remote controllers, right? These batteries have 1.5 volts of a potential difference. So here, let's see the potential difference of this one. If it is being printed, we can see it clearly. So in this dry cell, the smaller dry cell which we used in our, most of the times they have been printed, but there are some certain cases which the potential difference is not printed in a dry cell. So in this dry cell, we can't observe the potential difference. But if you take these dry cells also have 1.5. Normal dry cells that we use, right? They have 1.5 of volts, right? And I have another dry cell, this one. This is a rechargeable dry cell, a rechargeable one. And here you can see that, it's saying 3.7 volts and LiION. This refers to lithium ion. Lithium ion. Li means lithium. It's a type of a metal. So you will learn about lithium and all the other metals in your next grades. So these batteries, especially these lithium ion batteries, lithium ion batteries, we can recharge these batteries. So this is also a rechargeable battery. We can recharge and reuse these batteries. Okay, these dry cells can be recharged and we can use in different types of occasions. These dry cells we can recharge and reuse. And I have a very smaller dry cell like this. This is referred as the button cell. It's the button cell. So we use button cells most of the times in clocks and watches. In wristwatches we use these button cells. In a button cell, the positive and negative terminals can be observed. See here, you can observe the positive terminal. So this end is this top is the positive terminal, right? Here you can observe the positive sign. See, the positive sign can be observed here. And this end, this is the negative terminal. This end, the other end is the negative terminal. So these button cells are very smaller. Normally they have like about 2 volts most of the times, or 1.5, 1.7 volts, right? So we use these button cells or button cells in our wristwatches or in clocks, right? So these are the types of different batteries and dry cells that we come across in our day-to-day life, right? So remember, in normal dry cells like these and these, they have 1.5 volts. These, the 9-volt batteries, right? And the larger one, the lead acid accumulator, this one will be getting most of the times as a 12-volt one. Okay, so these are the more often dry cells and batteries that we can observe in our normal day-to-day life, right, my dear children? Now let's see how to measure the potential difference or the voltage in these
dry cells and batteries that I have. So I have the instrument which used to measure the voltage of a certain electric source. So this is called as the voltmeter. This instrument called the voltmeter. So we use voltmeter to measure the potential difference or the voltage in a certain electric source. So like in the ammeter, you can observe the V sign which stands for the volts or the voltmeter, and the scale here, the scale is marked from volts. The scale is marked from volts. Check the upper scale, not the below one but the upper scale, this one, the upper scale from here to here. In the upper scale you can observe from 0 to 15, right? So like in the ammeter, you can observe the scale but in volts from 0 to 15 in here, and there is another scale at the below starting from 3. Can you see that in here? You can observe 3, and you can see here there are 3 terminals, 1, 2 and 3, and one terminal is being marked with 15 volts and the other with 3 volts. So I told you in the earlier ammeter case, it's very convenient to use, or it's easy to make our work easy, or to connect in different instruments. We use these terminals. But the actual case in here is, if I'm going to plug in this to the 15 volt, if I'm going to plug in this thing to the 15 volt, then I have to use that 15 volt scale. To measure somewhat larger currents, we can use the 15 volt scale. So if I'm going to plug in this thing to the 3 volt thing, then we can measure by using the other scale, the smaller scale, 3 volt scale. So that's the use of these 2 terminals in here to measure somewhat larger volts and some smaller volts values, right? So now, first of all, I have here with me a somewhat larger battery, right? This battery is the lead acid accumulator, right? A car battery, right? So I'm going to now plug into 15 volt scale, as this is going to show somewhat larger value. I'm going to plug in for 15 scale, and now I'm going to connect these two to the terminals to observe how much of a volt is given from this lead acid accumulator or the battery. Now let's connect and see. I have connected to the 2 terminals of the lead acid accumulator, and let's observe how much is the reading is at more than 12.5. More than 12.5, because you know that from 10 to 15 there are 5 units. So exactly at the middle you can observe the 12.5. Exactly at the middle you can observe 12.5, but it's somewhat greater than 12.5, means that the reading is somewhat greater than the, see, the reading is somewhat greater than, just a one single unit greater than 12.5. So it is about 13, but greater than 12.5 and between 12.5 to 13, right? So this is my lead acid accumulator. It's about 13, right? Greater than 12.5 and it's about 13, the voltage. So now I am going to take the other smaller dry cells to measure the potential difference, right? I'll use the smaller dry cells to measure the potential difference, right? So let's measure the potential difference of these smaller dry cells now. Right now I'm going to check the voltage of this 9 volt dry cell. So here you can observe the 9 volt thing. See, the 9 volt thing can be clearly observed. Now let's see whether this dry cell gives a 9 volt of a potential difference when I'm going to connect it with the voltmeter here. So the positive end with the positive terminal and the negative end with the negative terminal. Okay. So you can see here the scale is somewhat less than 10. See, the scale is somewhat less than 10. Means that it is about 9. So the potential difference in this dry cell is accurately printed. 9 volts. Right? So this dry cell contains 9 volt of a potential difference. Right. So let's see. This one. Right. So this is a normal flashlight cell. Right. So in here you can observe, right, it's printed 1.5 volts. Here you can observe it's printed 1.5 volt. So now to measure 1.5 volts by using this voltmeter, I need to change the scale from here, means from 15 to 3. It's more convenient to use the smaller scale. So first I am going to eject this thing and plug it to 3 volt thing here. Now my scale is from 3 volts. Okay. So in here I have to use not the top scale but the bottom scale. So bottom scale is the one which is running from 0 to 3. Alright. Now let's connect and see. Positive with the positive terminal and the negative with the negative terminal, like this. So check the smaller scale, my dear children, not the top scale but the bottom scale. Check that one. Here you can observe 1, right? Below 5 you can observe 1 and below 10 you can observe 2. So the reading is exactly between 1 and 2, means the potential difference or the voltage in this dry cell is exactly 1.5 as it's been printed on the dry cell. We can get more accurate readings if you use the smaller scale when you are measuring smaller values of voltages. Right. Now I am going to use the other dry cells also. Now you can remember this is the rechargeable dry cell, right? So here it's been printed 3.7 volts but it haven't been charged up to its full potential. So now the potential difference is somewhat low as it's been dried up. So let's see how much of a volt has been remained within this dry cell. So I'm going to connect once again with the positive with positive and the negative one with the negative terminal. Right. So it's very less amount of a potential difference. See, very less amount of a potential difference can be observed. It's very less. Actually, we can't observe a good value in here. Yes, like about, see, very small because the dry cell is being dried up. We have to recharge it if you want to get a good potential difference, right? So it's about like 0.2. It's about 0.2 of volts, right? So from 3.7 volts, right? From 3.7 volts, it's just so it is just showing only 0.2 because the dry cell has been dried up. Right. Now the next one. The dry cells that we used in our remote controllers, right? The AAA size batteries. So we'll see how much is the potential difference in this one. So here, once again it runs to 1.5 volts. You could remember in the earlier activity I told you that these normal remote controller batteries are having about 1.5 volts. So my dry cell that I have right now, right, see, it's showing exactly 1.5 volts. See, 1.5 volts, right, the remote batteries. Then I have a small button cell, right? Now let's measure the potential difference of this button cell as well, right? So once again, I'm going to measure. So here, so I have connected, it's very small. See, it's very small. So I have connected the two terminals. So here you can observe like about 1.5 volts. 1.5 volts of a voltage can be observed. This dry cell is also dried up, right? When time is going to pass by, the electrical charges contained in a certain dry cell will dry up, right? So if the dry cell or the battery is rechargeable, then we can recharge it. If not, we have to throw it away, right? And we have to remove it and we have to replace it with another one, right? So here you can observe it's about 0.5 volts, right? 0.5 volts, right? So these are different types of dry cells that we can come across in our day-to-day life, and their voltages. So normally the voltage is being printed, but to make sure those values, I have measured the voltage by using a voltmeter, right? So let's discuss the further things related with the lesson at our classroom then.
Right, my dear children. Now we measured the potential difference in each of those cells, and you could observe like there was a certain amount of voltage in each of the cells, right? So up to a near value, we will write down our observations, right? Up to a nearest value. Here I am not mentioning the exact amount which we got from our experiment, because usually they have certain amount of voltage, right? So we'll mention those voltage, right? We'll mention those voltage, and I'll write down the most accurate one or most closer one, right? Usually these are the ones which are being printed on these each of dry cells or the batteries, right? So I'll mention the most accurate or the nearest one in here, right? So if you take a dry cell, usually in a dry cell, the voltage is 1.5 volts. 1.5 volts. Usually it's 1.5 volts in dry cells, right? So I'll mention AAA size. If you take a AAA size dry cell, the potential difference, AAA size means those remote controller batteries, right? So in TV remotes, we use these AAA size batteries, right? So AAA size battery, the voltage is about 1.5 volts. So in a lead acid accumulator, there was about 12.7 volts, right? About 12.7, 12.6 volts. But usually in a lead acid accumulator, right, the most accurate answer is, or the most correct answer is 12 volts. But it is somewhat larger than 12 volts, right? But usually it's mentioned as, or it's been printed as 12 volts, right? So we also got a somewhat greater reading than the 12 volts, but you know that here we are mentioning the accurate one or the nearest one. So I'll mention 12 volts in here. So in a lead acid accumulator, 12 volts. Then in the button cell, in a button cell there was about 3 volts, right? About 3 volts, right? So usually in a button cell there is about 3 volts, right? So 3 volts. Then in the 9 volt dry cell, 9 volts. Then there was a rechargeable cell also, right? That rechargeable cell was dried out, right? So usually in that rechargeable cells, usually we use these rechargeable cells in different types of instruments like remote controllers, then most of the times in our telephone batteries, then sometimes in some torch flashlights, right? In these types of instruments we use these rechargeable cells, right? Most of the rechargeable cells are about 3.7 volts, 3.7 volts, most of it, right? So that rechargeable cell that we used in our lab was somewhat dried out, right? So I'll mention usually it's 3.7 volts. So these are the voltage values that we measured out from this experiment, right? So in each of the cell, according to the type of the cell, there are different types of voltages in it, okay? So this is our final conclusion from our activity, right? So observation is quite simple. We got different types of, right? We got different types of voltage values for each of these cells. So these are the voltage values, right? These are nearest values, not the most accurate answers, okay? Right. Usually you can observe these things, right? These values we can observe. Usually we can observe these values, right? And the values which are printed on the dry cells or the cells are also these values, okay, my dear children? Now, the actual voltage amount may somewhat greater or somewhat lesser than these real amounts or the printed amounts, right? So you could observe that thing very clearly at the lead acid accumulator thing, right? There was about 12.7, 12.6 volt, but the voltage printed on the lead acid accumulator was 12 volts, right? So I have mentioned 12 volts in here also. So these are the values about the voltage or the potential difference in different types of dry cells and batteries, right? Right, my dear children. Now we know how to measure the potential difference, right? We discussed how to measure the potential difference. Now in this activity, we'll be measuring the potential difference between 2 points of a circuit using a voltmeter. Now using a voltmeter, we are going to measure the potential difference in a circuit, right? By taking a certain type of an instrument, here an electric bulb or else a torch bulb, we are going to connect it to a circuit using several dry cells. We are going to measure out the voltage of the bulb. How much is the voltage of the bulb by using the voltmeter here, right? So here we are discussing how to measure the voltage in a circuit, right? So we'll head on to see what are our materials first. So you are given with these materials, my dear children. What are those materials? So first of all, you will be needing dry cells to power up our circuit. Then a torch bulb, then a holder, to hold the torch bulb, voltmeter, switch, connecting wires. Connecting wires. So these are the materials that we need. Dry cell, a torch bulb, a holder, voltmeter, connecting wires, and the switch. Okay, so those are materials that we need. Right. Then you are given with the method of conducting the experiment. Okay. When you are using the electric bulb to measure the potential difference or the voltage, right? It's okay to connect a motor like this. A motor, right? So by that way we can get several readings. Means that first of all we can measure the potential difference of the electric torch bulb, right? Then after that we can measure out the potential difference of the motor, right? So if you can find out a motor, then we can conduct this activity more accurately. I mean, like, we can get a sound knowledge in connecting these voltmeters, and also we can compare the values very carefully, right? If you have two different instruments, a motor and an electric bulb. So when I'm conducting my activity, right, with the electric bulb, I'll use a motor as well, right? Okay, so in here also you are given with two different situations, two different figures separately, right? In the first instance, you can observe only the electric bulb, and in the second instance, electric bulb with the motor, right? Both of them are connected each other, right? Okay, my dear children. Now I'm going to ask you a simple question, right? I'm going to erase this. So first of all, I'll take this figure somewhat down so that you can see it very clearly. So I'm going to ask you a simple question. My simple question is, and then I'm going to erase this one as well so that you can clearly observe it, right? Then we'll erase that wire thing also. Okay. So I'll use the connection between wires right there. Okay. Observe the motor and the bulb separately in here. Observe it very clearly. Can you identify what type of a connection is there? What type of connection is it? Can you identify the connection between these two? Here and here. Can you identify it? It's easy to identify whether it is a parallel connection or else a series connection. What you have to do, just take one certain instrument, disconnect it, and see whether the other one is working or not. If the other one is not working, if the other one is also not working, then here we can observe a series connection. Even though the first instrument is being removed, right? Still the second instrument is going to work. Then here we can observe a parallel connection. So what I'm going to do is, I'm going to do a simple bit of a disconnection like this. So I have disconnected it now. So here the electricity is passing from positive terminal to here to here to here to the switch. Then here you can see that it's not going to pass to the bulb. Therefore, it's not going to pass towards the motor as well. So means that electricity should go through the bulb to the motor. If the electricity should go through the bulb to the motor, then bulb and motor is connected in a series connection. So here in the second figure, right, we need to connect the motor and the electric bulb or the torch bulb in a series connection, my dear children. You have to connect it in a series connection, right? So connect those two in a series connection, then finally connect it to the trisel and measure separately what happens with the voltage, right? Okay, so I'm going to take once again these things. Going to, right? Okay, so this is our figure then. I'm going to take this thing somewhat up. Right, now let's see what is our method in conducting this activity. So first of all, build the circuits according to the figures. You have to build out the two circuits according to the figures. Connect the voltmeter correctly to measure the potential difference between the two ends of the bulb first. So according to this figure 1 or the first figure, figure A, you have to first of all connect the electric bulb or the torch bulb to the circuit or to the dry cells with the switch like this, and we have to connect the voltmeter to measure the voltage. Measure and record the potential difference between the two ends of the bulb. We have to measure the potential difference and we have to mark how much is the potential difference. Then next point, remove the bulb and connect the electrical motor to the circuit. Then we have to remove the electric bulb and we have to connect the motor to the circuit. Okay. Switch on the circuit and measure the potential difference between the terminals of the motor. So we have to replace the bulb with the motor. I told you that earlier we'll be needing a motor as well, right? We'll be taking this motor in order to take somewhat more accurate readings, right? Accurate reading means here, by taking several readings in several instruments, we can compare those values and we can see like what kind of a thing is going to happen for the voltage, right? So therefore it's wise to use several, right? At least two of these instruments, right? So here I have used a torch bulb with a motor, right? Then connect both the bulb and the motor to the circuit as shown in the figure B above. Measure separately the potential difference between the terminals of the bulb and the motor using the voltmeter. So then after, you have to connect the two instruments in a series connection. Then separately we have to measure how much is the voltage by using our voltmeter. So this is the way of conducting our activity, right? This is the way of conducting our activity, my dear children. So we'll head on to the lab and we'll conduct this activity and we'll see what are our readings.
Right, my dear children. Now, let's see how to measure the voltage in a certain circuit, right? So I have a voltmeter here with me. Now, in this case, I'm going to teach you how to connect a voltmeter to a circuit and to get accurate readings by using this voltmeter, right? So always when you are connecting these voltmeters, we have to connect the voltmeter in a parallel connection. we have to connect the voltmeter in a parallel connection. Parallel connection means whatever the electric appliance which is connected to the circuit, and if you want to measure the voltage of that electric appliance, you have to directly connect these plus and minus terminals of the voltmeter to that electric appliance. You have to directly go and plug in these two terminals. That kind of a connection is referred as a parallel connection. So when I'm doing this activity, or when I'm conducting this activity, you can observe how does a parallel connection works, or how to connect a parallel connection more accurately. So let's conduct the activity and we'll see how to connect this voltmeter. Right, so I have several instruments in here, tricells, a holder with a bulb, a switch, then my voltmeter, some connecting wires, and a motor. So these are the materials that I have. So now I'm going to connect each of these instruments, and let's see how to connect the voltmeter in each of these instances. So first of all, I'll remove the motor and I'll take the bulb. So I have the bulb with me right now. So I'm going to connect by using my connecting wires the bulb to the circuit. So I have the switch here with me. One into the switch, another connecting wire, one into the bulb or the holder, right? The other into the other terminal, then once again back to the other dry cell. So this is the way of connection. Now you can see that I haven't connected the voltmeter yet. See, my voltmeter is in my hand right now. I haven't connected it, but my circuit is completed here. My circuit here is completed, right? So when I'm going to turn on this thing, the bulb should light up. See, you can observe it. The bulb has been lighted up. So in the earlier case, when we are connecting the ammeter, I have connected the ammeter so that the current flow through the ammeter and travel to the other appliance. But when connecting this voltmeter, we can't connect that voltmeter in that kind of a connection. So the earlier connection was referred as the series connection. Here we have to connect in a parallel connection. So parallel connection is like this. Now I'm going to disconnect this thing, right? Parallel connection is, now we are going to measure, now we are about to measure the potential difference or the voltage of this electrical appliance. So this electrical appliance is the bulb. So in that case, I have to connect for these two terminals, the terminals of the voltmeter, right? We should directly connect it to the two terminals, not through it like the ammeter. So now I am going to connect. So always check about the positive and negative terminals. So my red wire here starting from the positive terminal runs back and comes to the switch, and this is that positive terminal. So my red color should go to the, so this is the red color terminal of the voltmeter. Then black color terminal to the other one. Red color terminal is the positive terminal Black color one is the negative terminal. So here you can see that this is the positive terminal of the dry cell, which runs from here and comes to the switch, and from the switch it goes to here. So this is the positive terminal. So positive terminal is connected with the positive terminal of the voltmeter also, and negative with the negative terminal, right? Now I'm going to turn on the switch and let's see how much of a voltage can be obtained from this circuit, or how much of a voltage is flowing through this bulb. So I'm going to turn on and let's see. So the bulb lighted up. So we'll see the reading here, how much. The reading is, so here once again children, now I have plugged this terminal to 3 volt scale. So we have to get the 3 volt scale from here, right? So take the bottom scale, not the top one. So it passing somewhat 2.3. It's greater than 2.3 volts. So you can see 2.3 volts in here. So the voltage passing through this bulb is now 2.3 volts. So this is how to connect a voltmeter. So how we can observe whether a connection is a parallel connection? There is a more easier way to observe a parallel connection, right? It's like this. Now I told you that the voltmeter is connected in a parallel connection. So here you can observe 2.3 volts. Now I am going to show you how we can more conveniently, or how we can easily observe whether the connection is a parallel or a series. So you know that voltmeter has a parallel connection. So in a parallel connection, we can remove that appliance without troubling the other appliance. So if you remove this voltmeter from the circuit, there is no effect for the bulb, right? In a parallel connection, that's how the system works. Now, if you check your household electric circuits, means that in your houses, when you check those electric circuits, right? Those electric circuits are also have a parallel connection. When you turn on a switch in your room, only your room bulb will be lighted up, right? So when you turn on a fan in your room, the fan will work, right? If you want to disconnect that fan, then the fan can be disconnected by switching off the switch, right? The living room area is being controlled by a different circuit. So living room switches do not have any affection, or do not have any effect on the switches of your room. Living room is a different connection or different circuit. Your room is a different circuit. So that's how the parallel connection works. Now I'm going to show you that. I'm going to remove this. See? So I have disconnected the voltmeter, but still the bulb lights up. It's because that the voltmeter is having a parallel connection. Voltmeter is having a parallel connection. This is how to easily identify a parallel connection. If I'm going to disconnect a certain instrument from the circuit, even though I'm disconnecting it, the other instruments work, right? See once again. Now I have connected it. Once again it runs back to 2.3. And also the bulb is lighting up. When I'm going to disconnect it, bulb is going to still work, but the reading is not there. It's because that now this unit is not being connected with the circuit. So this type of a connection is the one which is referred as a parallel connection, right? So in a parallel connection, we can just remove the instrument without troubling without hurting any other electric appliance. Even though we are going to remove the appliance, the other appliances are going to work if the connection is parallel. So this is the most easiest way of identifying a parallel connection. Right, now I'm going to turn off this thing and we'll connect the motor by removing this bulb. So I'm going to remove the bulb and now I'm going to connect the motor, right? Now I'm going to connect the motor. So here, let's connect the motor. Right, so I have connected the motor. Now once again, you know that voltmeter should be connected in a parallel connection to measure the voltage of this motor. So now if I'm going to turn on the switch like this, you can see the motor works, right? It rotates, right? The fan is going to rotate. The fan is rotating, means that the motor is working. See? So the current is flowing through the motor. So there is a potential difference in the motor. So to check that potential difference, once again I'm going to use my voltmeter and I'm going to connect. So when you are connecting, check the terminals very carefully. So once again, this is the positive terminal, the red color terminal, which runs through the switch and which comes to this red color terminal of the motor. So my red color terminal of the voltmeter should go to this one like this, and the black color terminal to the other terminal of the motor like this. Right. Now let's turn on the switch and we'll measure the voltage in here. So the motor is rotating and the potential difference inside the motor is somewhat around 0.1. See, it's about 0.1. If I'm going to disconnect this thing, see. So it's about 1 volt, not 0.1, it's about 1 volt. See, the potential difference of the motor is about 1 volt, somewhat greater than 1 volt. So we'll assume that it is 1 volt. So the potential difference in the motor is 1 volt. You can observe the motor is working and the potential difference is 1 volts, right? 1 volt is the potential difference in the circuit of the motor, right? So I'll disconnect once again. See, this is the positive end of the motor. This is the negative terminal of the motor. So once again I'll connect. This is the negative terminal which runs to the negative terminal of the motor. And this is the positive terminal which runs to the positive terminal of the motor. So here once again you can observe the voltage. Voltage is 1 volt, about 1 volt. Right. So I'm going to remove the voltmeter once again. So you can see that as it has a parallel connection, still the motor works. So now I'm going to turn it off and let's connect both the light bulb and the motor to check the voltage. So I'm going to disconnect this thing. So now in this connection, when you are connecting the motor plus the light bulb, I'm going to use a parallel connection. Means that the electricity comes through the bulb and runs through the motor and goes to the dry cell, right? So let's connect in that kind of a way. So here we go, one end to the switch like this. So I'll disconnect the electric source. So this is the positive terminal which I'm going to connect it with the motor. Then after that, this is my light bulb. So I'm going to connect the light bulb terminal to the motor. So my dear children, see how does the electricity is going to pass in this circuit. So this is my positive terminal of the dry cell. So electricity should come from, or the current should come from positive terminal to this wire and should travel through the motor and through this wire, through the bulb, through the switch, once again back to the negative terminal. So if I am going to disconnect just one single instrument like this, then the whole circuit will break down. It's because that motor, bulb, switch and the dry cells all are connected in a series connection. That's the specialty in a series connection. If you disconnect one single end, the whole circuit will break down, right? Okay, so you could remember in the earlier case, when I'm connecting the voltmeter and when I'm disconnecting the voltmeter, even though it's been connected with the circuit or even though it's been disconnected with the circuit, there is no effect with the brightness or the operation of the bulb. Bulb is still operating. It's because that voltmeter has a parallel connection with the circuit. But in this way, if I'm going to disconnect the bulb, the whole circuit will break down. So I'm going to once again operate. See, now I'm going to turn on and let's see whether the two appliances are working or not. So here you can observe bulb and the motor both are working. The motor is rotating and also the bulb is lighted up. So when I'm going to disconnect, just one single disconnection is enough. So if I'm going to disconnect this thing, both of them will not work. It's because this motor and the bulb is having a series connection. If you disconnect, just one single instrument is enough to break down the whole circuit. Right, once again, if you connect this thing, it will work. See? So once again, if I'm going to connect it, it will work. So when once again I'm going to disconnect, both of them will not work. So this is how the series connection works. This is how the series connection works. Okay, now I'm going to measure how much is the voltage of the motor and the electric bulb in here, right? And to get some readings. So first of all, we'll measure the voltage of the motor in here. Now in the earlier case, the voltage was around 1 volt. When I'm operating this instrument, the motor, the voltage was about 1 volt. Now let's see how much is the voltage. So I have disconnected the circuit from here. So I'll connect it once again. Now I'm going to connect the motor to my voltmeter to check the potential difference or the voltage. So the positive terminal with the positive end, positive with the positive end, negative with the negative end. Right. So negative with the black color one is the negative one. So negative end with the negative end. Red color one is the positive one. So positive one end with the positive end. Right. Now let's observe how much is the voltage when I'm going to turn on the circuit. So here you can observe the reading. Reading is around 0.4 volts. You can see here the fan is working or the motor is rotating. The reading is about 0.4 volts. Now I'm going to show that the voltmeter has a parallel connection by disconnecting the voltmeter. See, if I'm going to disconnect the voltmeter, it won't affect. See, it won't affect the rotation of the motor or else the operation of the bulb. It's because that this one having a parallel connection. So I have disconnected it now. See, I have disconnected here. You can see the two terminals as well. So we can directly remove these in a parallel connection without troubling the others. So once again, if I'm going to connect, you can observe the potential difference. See, 0.4 volts can be observed. Right. So now I'm going to turn off the system once again and will measure how much is the voltage in the bulb. So we'll disconnect the voltmeter. Right, then I'm going to connect the voltmeter to the bulb in here, right? So when you are connecting, remember to check the terminals. So let's see what is the positive and negative terminal in here. So here, this is the black color end, which is the negative terminal, comes from here. Now this is my negative terminal then. This is my negative terminal. So I'm going to connect the negative terminal, the black color one, to this thing. And the other terminal, the red color one, to other end of the bulb. Now let's turn on the circuit, or let's enclose the circuit, and we'll see how much is the voltage between the two terminals of the light bulb. Right. So you can see the light bulb is working and the motor is also rotating. We'll see the reading. See, reading is like somewhat greater than 2, means that it is around 2.1. See, it's 2.1. So you can see that when you are connecting the appliances, when you are connecting these appliances in a series connection, we can see that the potential difference between each of the appliance is going to change or is going to differ from each other, right? So this is how to measure the voltage in a certain appliance. Remember, we have to directly plug the voltmeter for the two terminals, plus and minus terminals in the electric appliance, right? So this connection is referred as the parallel